We've made keychain hanger, we made a kitchen knife series, which sold out in a day, by the way, so thank you very much. You guys are awesome. But now it's time to stop with the Weenie Hut Junior builds and focus on what this channel is really about. Whipsaw, fantasy builds. It's about fantasy builds. It's not only about whipsaws. I don't really understand why you guys would think it is. Anyways, today I want to go back to a project that I made roughly 2 years ago, and since then a lot has changed. Mainly, you can see I'm standing in a building. The last one was made outside in a shipping container. The first version was definitely the cooler one. Let's just ignore the second one.
What is that?
Because we're going back and make the first version again, but an upgraded version with, you know, features that I couldn't do before because of tool limitations. But we are no longer limited because of the X-Tool Metal Fab CNC cutter. Yeah, so being able to cut everything very precise is pretty cool and all, but unfortunately that also means that I now have to think before starting with the project. I have to do everything on the computer. So today we're actually starting out with a test of the mechanism before building the real thing. Here's a quick recap of the two previous versions. The in-game folding blade is modeled after an OTF gravity mechanism, and those are illegal in Germany, so I had to redesign it as a folding mechanism. For both segments to have a sharp edge, the tip segment has to fold into the spine of the base segment, which demands some sort of lock for it to be functional. The first lock was too weak and the second too complicated, completely defeating the purpose of the sword. For this version I looked at modern folding knives and went through all available locking mechanisms to see which could be fitted into my sword design. The most promising turned out to be a crossbar lock. A spring pushes the crossbar in between two solid pieces of steel, creating a lock that relies on material strength rather than springiness, all while leaving the spine of the base segment open. Let's have a look if my sketch actually works. Now I have to remove the burr. You can apparently also cut it burr 3 with oxygen. But you know, honestly, I feel like changing the bottles all the time from argon to oxygen and then also compressed air probably takes more time for me than just taking this to the grinder. 20 seconds grinding off the burr and everything's golden. So now for the star of the show. Out of here! Ah. Hello. Please. Thank you. I was hoping that this might fit in here by friction. Nice. I mean, that's pretty much bang on, right? Now we need 2 of these and then also this piece. Now let's see if I can get this fiddled in here. Can already tell the first issue. The springs definitely need some sort of guide. So I also made these covers that were supposed to sit on the outside to cover everything up, and then you can see there's a little recess right here for the pin to stick through. What if I put them on the outside? Ooh, I already love this. I think this also means I can make the base a lot easier because I no longer have to cut out this recess, just this little one where the locking pin slides back and forth, and then I put a little hole in here so that I can fasten the spring from the outside. Wait a second, let me clamp this down. Now let's see, it's nicely locked. Pull it back, and now it rotates. Great! Oh! Wait a second. Gotta do things properly. Sorry, the metal fab is still running, so it's pretty loud, but let's do this. Okay. Quiet, everyone. Let's give this another try. Ooh, and it locks. Nice. Who would have thought testing stuff out before committing completely? It's actually a pretty good idea. But you know, since this is my first time, I don't want to overdo it. So let's jump into designing the rest of the blade. Here's where we started out with the test piece. And now one end of the lock sits on the tip segment and the other is in the cladding of the base segment. Both segments folding into each other look like this, which is what I modeled the handle around. Everything's pretty tightly packed with very little tolerances, so let's see how this works out. Okay, I tried around with different speeds and whoa, damn, I look futuristic. The important thing, I tried how fast I can go with this 2mm stock. Not only is it a lot faster if I get a higher speed, but also there's a lot less heat imparted, which means less warping. Just to show you how little heat is actually transferred. Cut through. I mean, this was just cut. The steel literally melted away and I can touch this, squeeze this. I mean, it's hot, but you can see there isn't any tempering colors whatsoever. And also have a look at this surface condition of the cut. This almost looks like it's already mirror polished, so pretty cool. So far so good. Looks pretty good. The small pieces, the last ones that were cut, clear bend in them. But it seems like it's only bent this way and the cuts that were placed are still completely straight. Okay, I did design these holes a little bit too big because you can see there's not really a friction fit. This doesn't fit at all, so I have to redo this part. Hey. We've got all of our pieces, so let's take them over to the belt grinder, clean them up nicely, and then we can see how everything fits together. Time to assemble. This has been a lot quicker than usually. So this is basically day 2 of working on this, and we've got all the parts ready. So let's see how I can screw it up. So first thing I think we should do is put the blade portion right in here into the base segment. Yeah, looks good. We'll line this up right here. And let's rotate this open. Looking good, looking good. Okay, so let's tack weld this. Got the carbon steel filler wire in there, so let's weld this up. Ah! What the hell am I doing? You know what? Maybe I should have tried welding before working on the actual piece. No matter how much technology I get, I always find a way to screw it up. Okay, I tried around with some scrap metal again, and I feel like I definitely know why that first attempt didn't work. First thing I always notice, I feel like if you select 2mm, they probably want to ensure that you've got a good weld route so that everything is structurally very good. With my projects, I usually don't really care too much about the weld route. It's more so hot gluing metal together, so it sort of works. I'd rather have a not 100% perfect connection and not have the weld route which interferes with anything behind my weld, because this has very tight tolerances. With that in mind, I reduced the settings from 2mm stock to 1mm, and then I also clamped this in a vise, which I feel like made a very big difference. And yeah, this looks a whole lot different. Now I'm kind of debating. There's actually no use for me to weld it all the way through, because I feel like having it like this would be strong enough to hold the blade segment in there. But it looks silly, right? But if I weld it all the way through, I might introduce a warp again. Alrighty, we're basically back where I screwed everything up. And this time I tack welded both sides on here. We can already do a little fit up check. Ooh, this is looking great. Now, if I remember correctly, let me do this. Last time this was very good. Oh. Good tolerances. Let's not. Oh. Let's not screw this up. I already ruined the tack weld right here. Yup. This is completely not on here anymore. One thing we've learned: don't play around with your part before properly welding it. Okay, pretty good. We've got no warping so far, but I really don't like the look of
these segmented weld lines, so I'll try to cover the gaps as well, and then hopefully it'll still look somewhat decent. I feel like the individual welds would be pretty great, but you know, overlapping them definitely caused some issues.
Let's see if the automatic lock works. Ooh, this is great. Now just quickly put the housing on here of the handle. Now the spring is protruding a little bit and the locking mechanism will also stick out a little bit because I need something to grab. So I think the best way to make sure everything fits into the handle casing, I feel like I should just cut out a recess. Mr. Kiste had it the wrong way around, so this is the correct orientation. The handle cladding moved in a little bit too far. Springs are bumping on here, so I can't close the thing. How do I solve this precisely? Trying to close this a little more. This one's still fine. Here the cladding hit the spring and bent it out of shape. Keeping it like this would be more dangerous than just hollowing out the whole section where the spring will be. Unfortunately, we do have some slight problems. This not being perfectly straight with the base segment isn't much of an issue, I have to say, because we could just grind that off to make them, you know, fit each other again. Holding it like this, you can tell it is slight little bit tilted that direction. Together with the handle segment, this is doing a curve. Especially the back is very bad. Jams up, isn't very smooth to begin with, so folding probably won't be as good. Then also we got this mess of trying different sizes for the recess of the crossbar lock. Now usually this is the part in the video where I would start taking out my angle grinder, persuading the piece to do what I wanted to do. But you know what? Thankfully, because of the metal fab, I just made a new one in like 2 hours. So new base segment, new handle piece, came up with a better recess, and now obviously both sides look completely the same. And then we take the new segment, this time perfectly straight and much better. This time I also only put a bead here, here and one in the middle, and then put a nicer weld on here along the whole thing. So the finish also looks quite a lot better. And then for the new handle piece, put this pin in here. And we still have a little bit of work to do because it's not 100% true, but it still has a little bit of give. This already folds a lot smoother. Good thing I've got the metal fab. Even if you are not going to buy one, definitely leave a WX tool down in the comments because yeah, I can finally do those builds a lot quicker, a lot. So all of these parts usually would probably take me about 2 or 3 weeks. I'm now on day 4. So 4 days instead of 3 weeks. Pretty good in my opinion. Was easier than I expected. Things to note when using the welder. Your workpiece definitely has to be clamped down because of the wire feed. It pushes everything away, and instead of pushing your welding gun forward, you push your material away. And in my case, it always leads to, you know, failed welds. Let's see if this works how I was hoping it would work. Maybe I over-shimmed a little bit. Let's shimmy this back up. This is horrible. You know, I can't deal with this right now. Jump to the next thing. This was fun. I mean, look at this weld right here. This starts here, goes all the way to the front. Perfect weld. Maybe I got carried away a little bit because it was so much fun. I didn't intend to weld all the way through because, you know, I think there was a reason why I didn't do that. Whoops. Oh, would you look at that? Fits in there perfectly now. And it's perfectly straight as well. No idea how that happened. But anyways, let's move forward. Okay, I did decide to not grind anything down from the blade and quench it full thickness, so hopefully there won't be any warping. Last time I had some issues. May need a little bit more time at the grinder, but at least hopefully I don't have to do the piece again. And now we wait for roughly 8 minutes. 8 minutes later. Well, my friends, you know, here I was thinking I could use this to educate maybe some of you that are going to do something that was as stupid as that. I learned from my last 2 videos, because someone was nice enough to educate me in the comments, that you have to be very careful of something called a chimney effect, which is basically taking anything that is hollowed out. So if we have like a square tube, this being the metal, if we quench this, everything in here, all of this, is boiling and rapidly shooting up this chimney. And then at the end, you've got a flamethrower shooting directly into your face. And I knew this was going to happen because it happened to me before. However, I thought that it happened to me on the very first video, because one segment is obviously just like this, and then the other segment is like this. And I thought the problem was that this right here is the chimney. I just went back to the videos to check the comment again, and then also look what happened in the last video, because I thought putting these two together like this closes up the chimney. But oh no, let me zoom in for you guys. There's the chimney. Right there. Beware of the chimney. But no matter what I do, seems like I just can't really escape this bend. So to accentuate it, it bends like this. I think that's probably just due to the construction, because this happened every single time with all of my versions. So maybe I have to actually start to incorporate this slight recurve into the design, because right now it just looks like it's a little bit bent. Just this subtle small curve, this tip point right here used to be here. But hey, everything's pretty straight except for this bend. The tip segment got a slight little curve to it, but I can shim temper that. Since the quench wasn't ideal, let's still check for hardness. And yeah, this is good. This is also good. Time for tempering. Alrighty, so I've got these hand sanded. They are looking pretty great. It's only 120 grit finish, but I definitely remember why I haven't hand sanded anything in so long. I've got something very special planned for the finish, because this steel, you can safely temper it up to 300 degrees Celsius and still get a good hardness. But most importantly, you don't get the blue brittleness you get with some steels. I put it in my heat treatment oven, get it nice and evenly up to 300 degrees Celsius, and then we'll spray a coat of oil on there that basically sets the tempering color on it, and hopefully we are left with a cool looking finish. But before we can do that, I have to weld on the connection pin right here. Great thing to note, you can tell the weld penetration on the base segment was fantastic. You can barely see anything. There are some spots where you can see slight little dots where the weld line is. We've got a very acceptable angle for the bevel. Bevel angle is very important for sharpness, because you have to imagine the blade is basically a wedge going into the material, and the duller the angle, the more metal is pushed against the material you're trying to cut, so you have more resistance and it doesn't seem as sharp. Just for comparison, these two, they are the same thickness. You can see how far the bevel goes towards the spine. Tells you how different the bevel angle has to be. Hopefully quite a lot sharper, because this this right here wasn't very sharp at all. I know it doesn't seem like much, but not having to worry about welding through these thin sheet metal pieces and, you know, messing up everything inside is a huge win for me, because I very much like to spend some more time and make all of that complicated work invisible, so you wouldn't know. Okay, degrease the whole blade. It'll most likely also be a little bit spotty because the weld seams and everything might look a little bit weird, but maybe it'll look good, so let's see. This will probably smoke like hell. Well, let's put something on. Oh, I thought this was a mist. Crap. Well, too late now. Well, I feel like I didn't leave this in long enough, because even the mono steel isn't the same temperature all the way through. Still a little smoky in here, but this is what I wanted. This looks pretty cool. I'm not a huge fan of how blotchy it is, so I guess we have to do it again. Okay, yeah, this didn't turn out the way I planned, and also not the way I was hoping for, but it is what it is. In some angle it looks purple, then it looks yellow, then it looks very blue. It is pretty cool. Sometimes it looks green. I mean, it's it's interesting. I don't really like it, but let's just leave it like this. Maybe some of you might like this. But let's move on to the next thing. I've got it attached to the handle, and you can see that this idea with the sliding hinge right here, it's an idea for certain. Not a good one. It's an idea, I guess. Really, nothing about this feels sturdy. It's only sturdy when the pin reaches the far back position and then it's at an angle. Now it feels pretty sturdy, but holding your hand right here, this doesn't make a very sturdy impression. I think I have to ditch the sliding hinge, which means we're back at the point where I'm going to take out my grinder and adjust everything so it somehow fits. Psych! I made a new one. So if you haven't already, be sure to write that WX tool down there in the comments. So made a new one, completely ditched the sliding handle. So now we got the OG version with just a normal hinge. You can see I kind of changed the design up a little bit as well, but this already looks a lot sturdier, even without the wedge piece in there. Ah, boy, that was nice. Thank you. I was holding my thumb right there. You can tell. So I was holding my thumb right here. So all of this metally goodness hit me right in the thumb. Working with this is no fun at all. All of this is just made to pinch your fingers in every which way you can imagine. But yeah. Everything fits together. We got a much slicker handle now. I was going to put wood veneer on here. Turns out I don't have any more wood veneer. I think I have a better solution. So I've drawn some scroll work, went over to my iPad, redrawn everything. You can definitely see the improvements. And then I put it into the Xtool Studio and then trace around everything again so that we can have a cutout of thin sheet metal that we can weld onto the side of the handle. And this is what that looks like. Looking absolutely great. I think this time I found the perfect application for the combined processing. I was just testing out the different speeds because I want to engrave my details I put on here, so I have them for the next step. But let's first cut out both of these. Okay, I also cleaned up the handle because I want to put a hot brushed brass finish on there. That's a mouthful once again. Put this in here. Okay, I don't think I can ignore the fact any longer that this doesn't look good at all. Let's just go back from, this looks like it belongs in a sewer to, hey, it's blade colored. Not only because I didn't like the color, but also since everything is metal, it scrapes. The dark finish accentuates all of those scratches. Meanwhile, on the silver side, I still got the same scratches, but you don't see them as much because they're both silver, obviously. Which is also why, even though this thing is already through a testing video, it still looks a lot better than just fitting up the handle on this side. So yeah, back to silver. And now the cool part is, because both pieces are welded together, it's way more effort than before. I wish that this would look better, and I want this one to look better because I'm a very big fan of the midnight blue finish, especially with gold and blue. But somehow this just feels like it's, right, with the rest of the blade being so silver. This is the more sensible option. This kind of sticks out like a sore thumb. I don't know. Honestly, designing the Crossguard probably gave me the most headache with this whole build. I tried my best to make this one as close to the in-game piece as possible. I like it. It looks cool, but it's also very impractical. All of these sharp points get caught on something when pulling it out, and I feel like the nice thing about this design is that it's so flat, so having this huge crossguard on here kind of defeats the purpose. This point digs into my stomach right here, and then when pulling it out, it's easy to get caught on some fabric. I really wanted to do something different with somewhat of the same aesthetic, and I tried different designs from something that was completely flat, which looked super boring. I don't know. I feel like it's already very difficult to make this aesthetically pleasing because the handle is so much bigger than the rest of the blade, because it has to be. And this one was the first one that looked somewhat promising. So it's designed asymmetrical because you have to keep the opening under here. As an inspiration, I took the crossguard of a Katzbalger, which is why I went for the S shape with the guard. So let's see how it'll look. Then this one goes onto the back side. I don't hate it, which I feel like is already better than most of the things I designed so far. Yeah, we'll go with this. Now, of course, we need a little more decoration, as always. Ooh, I really love how this is looking. This may be the comeback of the century. This looks great. Okay, let's weld it on there. So far so good. I think this came out looking pretty cool. Right now, if you're in a clinch, sorry if that's not the right term, but in the game, they often get to, oh, who's the strongest? Putting the swords together. Big ouch on the hand. So I thought we need another piece that's also on very many Renaissance pieces, which is this right here. Goes onto the backside. And now, blade slides down, gets caught here, and now your hand is a lot safer. Okay, it's time to jump forward a little bit. It's just a whole lot of welding and grinding and brushing and welding and grinding. So, bam, boom, bam, bam, and we're here. Alrighty, there we are finally. I got everything assembled except for the locking mechanism. It needed a lot of fit up to have the, oh, by the way, good thing about the S-guard, it can't hit your finger anymore, which is great. But now for the most important part, the crossbar locking mechanism. Hopefully everything is just a matter of assembly and that it works straight away. But first thing, we have to do the crossbar. First thing, we have to mark where the spring will sit. And now we'll use the poor man's lathe. And now the only thing left is to just take the spring and put it in this little hole. And then we should be able to... It doesn't fit. But no worries, I just have to make it a little bit thinner.
Why do all of these mechanisms always have to be so tiny? Can't I just make something huge?
Here it is. Still have to cut off the excess length, but oh, so far so good. So let's see how this works. Whew. Okay, and now moment of truth. Ooh, boy! Oh, that's really on there. Nice. Oh. Look at this. Oh. Oh. Looking good. Nice. Awesome. Exactly how I imagined. Can't believe it actually worked. Nice. Okay. Let me give this a clean up. Try to make everything as pretty as possible again. Sharpen the blade. And then let's have a look at the finished folding blade Mark III. Alrighty, I think we can definitely see an improvement. I do have to note that hitting this introduced a little bit of wiggle room, but I'm still very happy with the outcome. I mean, it's a tool, and this one definitely depreciates a little faster than a regular sword, but it can also fold into itself. Getting out of sword mode still is pretty quick, in my opinion. You just have to push the crossbar back so the lock disengages, and at the same time let go down here, and then you give it a little flick. I feel like deploying this turned out even better than the first one. For comparison, this one, and then this one. I think in terms of quality, you can definitely tell that there's a huge improvement. Now, for the most important part, for me at least, this and also the second one took me around, let's say a month, maybe 3 weeks to do. This one I made in 7 or 8 days. I think I can even take the time down to maybe 5 days, so I could do one in a week. I could sell these for 1,200 euros, so if that's something you'd be interested. It's definitely still very expensive, but I mean, have a look at custom swords and none of them fold into themselves. Let me know if you'd be interested in buying one. Maybe I'm like a small batch of like 3 or 5. If you want to have this one, it'll be up on my website with a pretty little discount because I mean, it's not quite factory new anymore. Fitting everything for the first time and trying different things definitely leaves some scratches, but it has a nice discount. So if you want to grab it, go onto my website. I'll link it in the description. Very, very special thanks to Xtool for sponsoring the Metal Fab. If you want to get something from them, I've got an affiliate link. You don't pay anything extra. I get a little kickback. So you'd be doing me a huge favor. I know some of you already did that. Thank you very much. And another special thanks to my patrons. If you want to watch these videos ad-free, I also upload them on my Patreon. You can join for just €1 a month. If you want to keep your ad block active and still support me as a creator, that's a great way to do it. We're almost done with the Metal Fab series. I think you'll be very excited about the last one. And now to close this video off, I think there's one thing we definitely have to do.